All right, so the actual mortise and tenon layout, this is just a piece of plywood and a Sharpie. Not nearly accurate, but I want to do it just to show you as a representation. Okay, so what I built this as is kind of a representation that I'd seen it in a couple different instances, and this just made sense to me. A 12-inch, because that's about as big as I'm ever going to personally go on a small building. Zero center rule. Okay, you have 1 through 6 inch integers both directions. Why that's handy is, so saying I was measuring the end of a timber right now, and this thing is exactly 6 1/4 inches, I'm going to be able to put my 0 notch center and center that over the timber to say, oh, I can see I'm just a hair heavy of 3 and just a hair heavy of 3 on this 6-inch milled timber. And now at the end of my timber, I can just plain boop, make that mark. And this is going to become handy in several ways, because on the opposite end, say this is the other end of my short timber, I can find my center there, throw a string line between them and connect a straight string line, finding me dead center of my timber. Even if it takes a small curve or it's slightly rolling, I can take my chosen arris, my best square side, mark center of my timber, and base my layout off of a good straight line. Now, that's why a center rule is important. I also put notches in here at 3/4 and 1 inch away, meaning both sizes, the 1.5 inch and the 2 inch, give you a very quick layout reference. Okay, if you're marking off lines or scribing or doing anything with like a, like an actual straight edge, but you very quickly in these notches can find 3/4, which is your 1.5 inch. That's your 1.5 inch here inside the tenon layout. So say you've gotten to the point where you've used one of these, and so you use the end of a timber and say, well, these are centered tenons, because one of the most traditional things is that you'll do 1.5 inch, or 2 inch, okay, off of a side. You say, yep, I'm building a small building that's going to get siding, so everything needs to be flush. When you lay out intersecting members, your mortise or pocket would like to be the same as your tenon setup. So you often base the size of your timbers to be routine with each other. You can use center ruled, or you can go offset, and this is already perfectly laid out to trace the inside in the front to back. Okay, and you're already going to have 1.5 inch from the edge, 1.5 inch cavity that you can choose the length of and mark square and say, yup, it needs to be just a hair heavy of 6 inches because I have a 6-inch tenon going in here being joined by the next member. Likewise, okay, say if this is the end of my timber, I can use the center rule to find my center and mark all that. And then I could have marked the center of the timber where there's a long straight string line. Now what's nice is I put little notches here in this inside section, so that if you have a string line running the entire distance, I can now line up, an inked or whatever string line to the center of my internal here, of my internal opening, and then trace this whole thing, or trace it to the number of inches I need. I might need to go, here's my end, here is 6 inches, or my 0 to 6. I can make a 6-inch tenon centered right about the center line. And the beauty of it is, as long as your line that you snapped on your timber is from here into this other notch, you're dead center inside of that. You'll be able to make any distance tenon that you want. Likewise, a mortise, if you're in the center of a timber and you found with a string line the dead center of your timber to put a mortise pocket for a centered mortise in, you can lay this out on that string line and find dimensions. If you say, oh, I've got to be 47.5 inches from the shoulder, and then that's about here, and then I want it to be 6 inches long, so from 4 over here to 2, etc., whatever gets you to 6 inches, and then trace that out, or move this over to where it's squared right up, and just trace that out and draw the line, mark it with a square. This does 60% of your marking, other than a speed square, a large framing square, a couple different tools that almost everybody should have. But that's really meant to be the beauty of it. This is a simple template compared to your several $100 ones. It's just getting you through the basics of understanding why and when things are laid out, right? It helps you find center. I've got some quick set marks for 1.5 inch and 2 inch tenoning, and then I have the set be an 1.5 inch, or a 2 inch pre-made for setting common mortises. That center finding mark on the actual pocket cutout is just nice, because if you are to snap a line and go off of center, you know you're squared already because you found center. This makes you perfectly squared to the center of your timber, even if the timber is live edge, making a whole craziness. So that's kind of the basics of it. I mean, the method for cutting, all that kind of stuff. Follow Pickles Timber Frames on YouTube. You know, Big Beams Timber Frames, one of the moderators of the group that I'm a big part of, Timber Frame Apprentice, teaches a school here in New York. There's more than a dozen large popular schools across the country that teach square rule timber framing, mill rule timber framing. And it's a pretty simple set of principles. If you already know some carpentry, some hand tools, some whatever, you know, you're ultimately kind of doing giant Lincoln log or Lego work. You're making large pre-made pieces that fit into each other and then are pinned in place so they don't move. And the loads and forces of a building is a whole other discussion for like design principles and why things work the way they work. But if you get plans off of like Timber Frame HQ or something simple, you know, they're going to give you very precise measurements. If you study square rule timber framing and you don't like those precise measurements, or your timbers aren't perfect, or all that kind of stuff, you can literally learn to say, well, I know my building is an 8 foot by 8 foot, which means if I'm using 6 by 6s and I can perfectly make them 5 inches and 5 inches, you know, my 8 foot now just became 8 foot 2, because those are going to get milled into 5 by 5, the perfect timber within the timber. When I find my perfect square side and cut off my shoulders, I know I can make the math work when you follow these things. So, you know, your side guide with all these common markings, just faster to find. You know, if you're squared up on the edge of a board, that's a pretty accurate 5 inch, 5.5, 7, 7.5, etc. Subtracting into a perfect number from an imperfectly milled timber. And then your ruler is always your guiding edge, and that's going to be your inch and a half offset, or 2 inch offset for something that's oriented to the side of a timber, meaning it's something that will probably receive walls or a cladding of some kind. And if you're doing centered work, I've provided a center rule not just inside the layout, but right on the ruling sides as well, so that you can do much faster layout with nothing more than this tool, a string line, a speed square, and a couple other items. And then having the fanciness of mortisers and specialty chisels versus just generic chisels. There's a whole lot that can be said for the types of tools you use, but any guy with some hand saws, a small drill, other things, ingenuity, and some time can still raise a timber frame structure without all the crazy toys. But this I thought was a pretty nice, affordable method to get people through the basics of doing the short math of, you know, getting their first couple small buildings done and understanding where it comes from, and just speed up some of your layout.